Engineers play an important role in the stewardship of the environment. And to understand the environment better, we have to understand the atmosphere. The atmosphere is one big part of the environment in the world where we are living. To understand our world better, we have to understand the chemistry of the atmosphere. And this is topic 9. We have to study the history of the atmosphere, how the atmosphere we have today has changed. By examining rocks that laid down Earth's history, we could piece together a story of how our atmosphere has changed. 4.5 billion years ago, when the Earth had cooled enough for the surface rocks to solidify, we believe the atmosphere was made mostly of nitrogen, carbon dioxide, methane, ammonia, and water vapor. Within 800 million years, life had evolved in the oceans. By 3.2 billion years ago, photosynthesis had evolved with the first oxygen-producing cyanobacteria similar to today's blue-green algae. At first, the oxygen given off simply reacted with the rocks. Gradually, the oxygen started to build up inside the ocean, and these oxygen molecules started to bubble up in the atmosphere. To start with, the oxygen was a toxic gas, very harmful to the life forms in those times. But soon, life evolved to make use of the oxygen through aerobic respiration. By 2 billion years ago, about halfway through the Earth's history, there was oxygen in the atmosphere. When scientists look at the stars for signs of life on planets that orbit around them, the presence of oxygen in the atmosphere would be a sure sign that life would take hope. With the presence of oxygen, ozone could form in the upper atmosphere. And this ozone prevents dangerous ultraviolet light from the sun reaching the land. Before the ozone was formed, life would only exist under the water where the ultraviolet could not reach. However, life did not invade the land immediately with the ozone in its place. Every life form started under the water protected from the ultraviolet rays. It took a big evolutionary step for plants which need water to give it support. After 400 million years ago, 100 million years after the Cambrian explosion, life finally learned to live on land. And this is the Cambrian explosion. It was an event that happened 541 million years ago, when most major animal phyla appeared in the fossil record. It lasted for about 20 to 25 million years. It resulted in the divergence of most modern metazoan phyla. The event was accompanied by major diversification of other organisms. The atmosphere remains much the same until the 20th century. where mostly we have nitrogen, tiny amount of carbon dioxide, and oxygen. The carbon dioxide is just enough to give carbon to plants for photosynthesis. However, 100 years ago, another living organism started to change the atmosphere. This organism found seeds of coal, pockets of oil, and natural gas underground and began extracting them and reacting them with oxygen in the atmosphere, increasing the carbon dioxide concentration of the atmosphere. These organisms are the humans, mankind, the name of all the organism who began throwing other unwanted materials into the atmosphere. It's the presence of this life in this planet that had caused the atmosphere to change. First is the evolution of oxygen by the cyanobacteria 2 billion years ago. Then very recently, we learned to combine fossil fuels with oxygen to provide energy for our evolving lifestyle. What is the composition of the atmosphere? Nitrogen is 78%, oxygen is 21%, argon is 0.93%, and carbon dioxide is 0.0036%. Neon, helium, krypton, xenon, hydrogen, and other forms of gases also is a composition of the atmosphere in smaller amounts. Oxygen will be almost in negligible quantity at the height of 120 kilometers. Carbon dioxide and water vapor are found only up to 90 kilometers from the surface of the Earth. Ozone is found between 10 and 50 kilometers above the Earth's surface. Carbon dioxide is transparent to the incoming solar radiation but opaque to the outgoing terrestrial radiation. Water vapor, it decreases with altitude. It also decreases from the equator towards the pole's surface. The higher concentration of dust particles is found in subtropical and temperature regions due to dry winds in comparison to equatorial and polar regions. These are the layers of the atmosphere: the troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. The troposphere has a height from 8 to 18 kilometers from the Earth's surface. The thickness is more at the equator. Dust particles, water vapor are found in the troposphere. All changes in weather take place at this level. Temperature decreases at the rate of 1 degree centigrade for every 165 meters of height. The zone separating the troposphere from the stratosphere is known as the tropopause. The stratosphere is found above the tropopause and extends up to a height of 50 kilometers, and it contains the ozone layer. The mesosphere lies above the stratosphere. It extends up to a height of 80 kilometers. Temperature decreases with height. The upper limit of the mesosphere is known as the mesopause. The ionosphere is between 80 and 400 kilometers above the mesopause. It contains electrically charged particles known as ions, and hence it is known as the ionosphere. Radio waves transmitted from the Earth are reflected back to the Earth by this layer. The exosphere is the uppermost layer of the atmosphere above the thermosphere. There are different phenomena in the outer layers of the atmosphere. The aurora. It is sometimes referred to as a polar light. It is a natural light display in the sky, predominantly seen in the high altitude in the Arctic and Antarctic regions. How is aurora produced? Auroras are produced when the magnetosphere is sufficiently disturbed by the solar wind that the trajectories of charged particles in both solar wind and magnetospheric plasma, mainly in the form of electrons and protons, precipitate them into the upper atmosphere, or that is the thermosphere and exosphere. The resulting ionization and excitation of the atmospheric constituents emits light of varying color and complexity. The form of the aurora, occurring within bands around both polar regions, is also dependent on the amount of acceleration imparted to the precipitating particles. The aurora borealis. Auroras seen within the auroral oval may be directly overhead, but from farther away they illuminate the poleward horizon as a greenish glow or sometimes a faint red, as if the sun were rising from an unusual direction. Aurora australis has features that are almost identical to the aurora borealis and changes simultaneously with changes in the northern auroral zone. It is visible from high southern latitudes in Antarctica, South America, New Zealand, and Australia. What are some causes of the auroras? Number one is a quiescent solar wind flowing past the Earth's magnetosphere steadily interacts with it and can both inject solar wind particles directly onto the geomagnetic field lines that are open, as opposed to being closed in the opposite hemisphere and provide diffusion through the bow shock. Geomagnetic disturbance from an enhanced solar wind causes distortions of the magnetotail or the magnetic substorms. Acceleration of auroral charged particles invariably accompanies a magnetospheric disturbance that causes an aurora. What is ozone depletion? 15 to 35 kilometers above the Earth's surface, a gas called ozone. A gas called ozone is surrounding our planet. The ozone layer acts as a barrier between Earth and the ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. From the 5 layers in the atmosphere, the second layer is the stratosphere. It contains the ozone layer. The ozone layer is made of a highly reactive molecule called the ozone. The ozone contains three atoms of oxygen. Ozone is a trace gas in the atmosphere. There are only three molecules of ozone for every 10 million molecules of air. The ozone layer acts as the Earth's sunscreen. The ozone layer absorbs about 98% of damaging ultraviolet light rays. The ozone layer has been gotten thinner. Chemicals called chlorofluorocarbons or CFCs are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are normally found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down in substances that include chlorine. The chlorine reacts with the oxygen in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes. Ozone layer damages or ozone holes are more like thinner patches with the thinnest areas near the poles. The ozone layer above the Antarctic has been impacted by pollution since the mid-1980s. This is in October of 1981, 1982, 1983, 1984, 1985, 1986, 1987, 1988, 1989, 1990, 1991, 1992. The regions at lower temperature speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs are currently in the atmosphere were emitted by industrialized countries in the northern hemisphere. In 1989, the world came together as one to battle the ozone layer depletion. Since then, the Montreal Protocol was formed and it banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere had been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years from now. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles. And these are the predicted ozone levels. This was in 1971, and this will be 2017. By 2041, the ozone hole will start to shrink. And this will be the projected ozone hole by 2065 if we continue to ban all ozone-depleting substances in the world. We have to act as one and obey what the Montreal Protocol had given us.
Let me share with you one of the greatest success stories of environment negotiations ever. Indeed, it may be one of the greatest success stories of any sort of negotiations on this planet.
In our long history, there is one unprecedented act of humanity in which every country on Earth came together to protect the future of life on Earth. The Montreal Protocol.
The story of the Montreal Protocol is in some ways also the story of the 20th century. Something that was a great invention, namely a chemical chlorofluorocarbon, had unintended consequences that suddenly became a planetary problem.
It all began with a good idea. In the 1920s, coolants in refrigerators were so toxic that a leak could kill you. So we invented safer chemicals to do the job, CFCs.
The wonder chemicals of the 20th century.
They were so versatile, people's lives were transformed. But in 1974, Sherwood Rowland and Mario Molina predicted that the Earth's natural sun shield, the ozone layer, was being eaten by CFCs at a terrifying rate.
We felt a great responsibility to actually warn society that something could happen.
All eyes turned to the ozone layer. And sure enough, there was an enormous hole in the stratosphere.
It was such a shocking revelation. Over half the ozone layer destroyed above Antarctica in a decade.
If the destruction wasn't stopped, we'd be at risk from lethal levels of UV radiation.
We'd be in dead trouble. We'll have a blind, burnt population.
Faced with this global threat, the world came together to take action. And in 1987, more than 30 countries agreed to phase out the production of CFCs and signed the Montreal Protocol. Over the 3 decades since, the rest of the world's nations have signed up. Together, they've taken on the greatest planetary repair job ever attempted.
It's absolutely terrifying to work on a project that's so important because you know that failure is not an option.
Making the Montreal Protocol a success has taken brilliant minds.
We are working to protect human life.
It has taken determination.
It has made more progress than any other environmental convention in the world.
If the countries of the world engaged in similar deliberations for every issue that faces our world, I would be very happy.
And it has taken ingenuity from an extraordinary global community.
We always have our disagreements, and at the end of the day we have our agreement.
And it has worked. With CFCs banned, the ozone hole is healing. Now it's time to take action again.
You need passion, you need leadership to change the Montreal Protocol into an even better treaty. Victory is within our grasp.
There's only one Earth. We have only one Earth to protect. We cannot lose this one.
Once more, we must come together to protect the future of our planet.
To you, the delegates, and as somebody who considers himself part of the Montreal Protocol family, as you meet in Kigali, look to history, remember where the Montreal Protocol started off from, and please help the world to take the next step. There is need for everybody to compromise, but sometimes out of small steps towards one another, big things can happen, and you, as a family of the Montreal Protocol, have demonstrated that time and time again.
How acid rain forms, we have to know. Clean rainwater is slightly acidic. It has a pH value of around 5.6. This is because some of the carbon dioxide in air dissolves in rainwater to form carbonic acid. If the rainwater has a pH value than 5.6, it is considered as an acid rain. The burning of fossil fuels in companies, vehicles, and power stations gives large amounts of air pollutants. Some of the air pollutants are acidic gases. Acidic gases such as sulfur and nitrogen oxides. When these acidic gases dissolve in the water droplets in air, acids are formed. The acidic forces then join to form the clouds. When clouds become heavy, the acidic water droplets fall to the ground as an acid rain. How is the photochemical smog formed? When fossil fuels are burnt, many pollutants are emitted. Among those two of the pollutants are hydrocarbons and nitric acid. When this can build up to sufficiently high levels, chain reaction occurs. Nitrogen oxide reacts with air converted into nitrogen dioxide. It absorbs sunlight, energy, and breaks up into nitrogen oxide and free oxygen. The free oxygen reacts with oxygen to produce the ozone. This formed ozone reacts with nitrogen dioxide to give nitrogen dioxide. The ozone and nitrogen dioxide formed in the above reactions can react with unburned hydrocarbons in the polluted air to produce formaldehyde, acrolein, and peroxyacetyl nitrate. What are the effects of photochemical smog? The most common photochemical smog are ozone, nitric acid, formaldehyde, acrolein, and peroxyacetyl nitrate. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritate the nose and throat, and their high concentrations causes headache, chest pains, and dryness of the throat. Photochemical smog leads to cracking of rubber and extensive damage to plant life. We have to control photochemical smog. If we control the primary precursors of photochemical smog such as nitrogen dioxide and hydrocarbons, the secondary precursors such as ozone and PAN, the photochemical smog will automatically be reduced by certain plants. Plants like the pinus, the juniperus, quercus, pyrus, vitis. We have to understand also indoor air pollution. Indoor air pollution can cause health issues like dizziness, asthma, and allergies. The most common method of preventing indoor air pollution is the installation of ventilation systems, which will be part of your designs in the future. Researchers found a cheaper way to overcome indoor air pollution, and this will be using houseplants. Buildings can have high levels of VOCs, or volatile organic compounds. Volatile organic compounds could be acetone, benzene, and formaldehyde. VOCs can come from paints. They could even come from your furnitures. They could come from printers, and of course from cleaning supplies, and of course again your clothes. Surrounding oneself with houseplants can combat the potential harmful effects of VOCs. Sample houseplants that reduces indoor VOCs could be the jade plant, spider plants, the bromelae, Caribbean tree cactus, and the dracena. Our climate is changing. Temperatures in general are increasing in our planet. Sea levels are rising. The ice is melting in the north and south poles. One reason for the melting is the greenhouse effect. What is the greenhouse effect all about? A greenhouse is something useful. It helps us grow things like tomatoes out of season. That is because it is nice and warm inside the greenhouse. The sunlight enters, and visible light penetrates the glass. The light is also partly absorbed by the plants and the soil. The light is also reflected outside in the form of heat radiation. As a result, temperature rise inside the greenhouse. The planet Earth obtains warmth in a similar way to the greenhouse. It is fortunate because otherwise we cannot survive. Without the natural greenhouse effect, the temperature in our planet will be negative 18 degrees centigrade as an average, and not the average 15 degrees Celsius above freezing. Sunlight penetrates the gaseous layers of the atmosphere. Sunlight is partly absorbed and partly reflected, just like in a greenhouse. Small particles in the air ensure that the percentage of the reflected radiation is sent back to our planet. However, humans caused a lot of pollution by producing large amounts of carbon dioxide, methane, and nitrous oxide. The small particles increase in number, and the result is just like a greenhouse. So when an increased amount of radiation is sent back to Earth and the heat is unable to escape, the temperature rises constantly in our planet. What can we do about global warming? If every Filipino plants a tree, carbon dioxide emission will be cut by 2 kilograms every year. Filipinos can make a difference by recycling. Every household that recycles will be saving 91 kilograms of carbon dioxide every year. Switching to high energy saving light bulbs saves 20 kilograms of carbon dioxide a year. We can also cut in the use of wasted water. If we all just turn off the tap water when we brush our teeth. None of these examples will change huge in our lifestyle. If we all do them, we can save 13 tons of carbon dioxide a year. Giving up our cars can make a huge difference. We can save 2 tons of carbon dioxide per year. If we all give up our cars in Southeast Asia, we can save about 70 million tons of carbon dioxide emission every year. What about if Southeast Asians will give up meat, particularly beef? We can save 79 million tons of carbon dioxide. Giving up beef alone can make a big impact. Producing beef creates 5 times more greenhouse gases than other meats. Can you give up the steak to help save the planet?
For 2.5 million years, the Earth's climate has fluctuated, cycling from ice ages to warmer periods. But in the last century, the planet's temperature has risen unusually fast, about 1.2
We are all members of just one race, the human race, and we share one home, the planet Earth. We all have the same basic aspirations for life, liberty, and happiness. We should not be separated by religion or discriminated because of skin color, sexual orientation, or other prejudices. The universe is governed by one overarching set of laws, the laws of nature and science. To lead a happy, productive, and virtuous life does not require the belief in an invisible, all-powerful, supernatural being that is aware of our thoughts and actions and can intercede in our daily lives. On the contrary, within the bounds of natural laws, we are the masters of our own destinies and are responsible for the actions we take and their consequences. There is no supernatural being or force that will come to our rescue if we as individuals or as a human community fail to make the right choices. We are capable of establishing on our own an effective set of guidelines that allow each individual to seek happiness and live harmoniously with each other and with nature. The human community, who must exist within the laws of nature and science, needs to respect and preserve the environment that nature has bestowed. Humanity must take urgent action to reverse the course of climate change that is already affecting the biosphere or threaten humanity's very existence and the future of all the species populating planet Earth. Every human being is entitled to a basic set of rights as follows: the right to life and liberty. Liberty being the freedom to do what which injures neither another person nor the environment. The right to be happy, being free from discrimination based on a person's race, color, sex, sexual orientation, religious or other personal beliefs, nationality, or social origin. Not being held in slavery or servitude, being able to live in a free and open society with the right to vote, free speech, a basic education, and an environment free of harmful pollution. Have an opportunity for honest employment that provides at a minimum a sufficient income to cover basic needs for themselves and their families. Have access to quality, affordable health care. After more than 2,000 years, religion has failed at solving humanity's most serious problems and has nothing to offer for the greatest problem we have ever faced, the climate change. We have to be one and battle and win this war. We can save our planet. We can save our planet. Together, we will fight as one. Thank you for listening.